In this video, we'll take a look at two compound interest calculations, both of which are at the end of the notes package on Schoology. So we've got our compound interest formula, identifying the variables with A being the amount that is in the account at the end of the investment, P being the amount that has been invested or initial contribution, what did they start with, R being the rate, just as in simple interest where we show it as a decimal, T for time, again in years, and the new variable is N for compounding period. So how many times are we going to be getting interest on interest? We've got our time chart here, if you will. So semi-monthly being 24, that's 2 payments in every month, so 12 times 2 to make 24. And bi-weekly is 26, where you have your weekly payments and you divide it by 2. So every second week there's a compound. So that's our basic formula. And slide this guy in here. So here we have Christine. She has a savings account that gets an amazing 9% compounded monthly. So what we want to do first of all is just sort of identify what we've got in the question. So what is every number that we're seeing? Sometimes there's numbers there to throw us off, but in this case, when we say that she has this amount in her savings, that is really our principal. So we know what the principal is. In terms of the rate, we could see that there, but we do want to show that as a decimal. So we want to take that 9%, divide by 100 to get 0.09. Monthly is our N, so that's our compounding period. So in 1 year, there'll be 12 compounds. And this question has to be over 6 months. There we go. We're missing the T. So in terms of 6 months, we want to divide that by 12 months to get 0.5 years. And that'll be our T. Lovely. So the thing that we're looking for is how much is in her account, and that's our A. This is fantastic. We can go ahead and set up our compound interest formula. So we'll have A here. We'll use for P 875. 83. We have a 1 plus 0.09 over 12. So the rate over the number of compounds periods, make sure that your rate is in its decimal form. And then we're going to use the number of compounds times the time as the exponent. So my recommendation based on your calculator is to solve for the inside of this bracket, solve for that exponent, and then just rewrite everything so that we actually can see where we're at. The more decimals, the better. As you start to round, you start to introduce inaccuracies. So work with your calculator in order to first do the division and then do the addition. The more you do of these, the easier it will get. And then the final, this is to the power. So you're going to look for this button on your calculator. Maybe it'll look like something like that. But you're going to need to find the exponent. So it's the base to the power of 6. Final answer, $915.99. This is the amount in the account. So follow-up question, how much interest does she earn? Well, for interest, we will take the amount that's in her account and subtract it from what we began with, or the principal. So here we've got $915.99 in the account, which is sort of 6 months down the road. We started with $875. And so the interest will be $40.16. So to kind of kick it up a notch, that was sort of your run-of-the-mill compound interest calculation, and it is showing sort of the basics for how to show your steps. This is the second example that's in that notes, or the final example that's in that notes, where we know what the account has at the end. So Ram's parents, they've got an RESP. They started it when he was 10 years old. It's never too late. And they threw a bunch of money in. So that's the question, is how much did they put in at the beginning? So what we're solving for is our principal. We know that there's $7,000 at the end. We know the rate is 4%. We could see that it's compounded monthly. And in terms of the years, they began at 10 years old, and now this is at 18. So we're going to let this investment ride for 8 years. So when we set up our equation, we have to be really careful that the 7,000 goes in the place of the A. And that for P, either if you want to use an X or the letter P that represents the variable. So the rate over the compounding periods, and then the compounding periods times time. So I, again, would recommend solve for this inner bracket, solve for that multiplication, and rewrite. And if we do the inner bracket times the exponent, we'll get this. So this is a little bit different than the basic style questions, because again, we want to get P alone on one side. We just want to know only what P is. So to break this multiplication between P and the value, we would unmultiply or divide. So that becomes 1, and we get left with 1P, and we'll just do the same thing on the other side. So $5,085.73 was the initial investment.